Hey everybody, here we are in chapter 8. We're at the end. We're looking at section 810 and we're going to talk about a pretty heavy topic, systems of equations. It's a real Algebra 1 topic that we're going to tackle here in pre-algebra. I know you got the stuff for it. Let's just get started. So a couple things we need to start off with is the vocabulary, and the two vocabulary terms we're going to talk about would be systems of equations. And what that is a collection of two or more equations where the equations share the same variables. And so, for instance, a system of equations could look like 2x plus 3y is equal to 7, and then x minus 5y equals 8. Here are two equations. They share the same variables. And basically, we can talk about these two equations, and we can talk about the solutions of them and see if they have any solutions in common. So that's generally what we talk about when we're trying to solve a system of equations. And what that means is does there exist some x and y pair that satisfies this equation and this equation at the same time? So the cool thing about systems of equations is that if you can graph these equations and you see how the equations possibly intersect, those intersection points are the solutions. Those are the XY points that satisfies both equations. And we're going to talk about the one algebraic method, so that brings us down to this vocabulary term, substitution. In the case of substitution, in this context, substitution is an algebraic method of solving systems of linear equations. So basically what we're going to end up doing is taking one equation and substituting it into another to reveal this XY pair that's going to help us out. So let's look at some examples solved by graphing. So in this case, we could solve an equation like this by graphing. So what I'm going to do is I'm actually going to be a little bit lazy. Lazy is probably not what I want to say, but I'm going to be more specific by actually using Desmos. So I'm going to pull up Desmos, which we know is that graphing calculator that I think is awesome. And I want you guys to hold on to this for me. We're looking at two equations, y is equal to x and y is equal to negative 3x plus 4. You guys are really good at graphing equations. Let me do a real quick reminder of how to graph equations. So I would graph this. Let's say I'm going to talk about this equation is y equals x. So if x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. So you'll get this beautiful diagonal line here for what I'm going to refer to as my orange equation. And I'll pull up Desmos in a second, just relax. And then here I'm getting y is equal to negative 3x plus 4, which we can graph by going to the y-intercept, 1, 2, 3, 4, starting there, and then rocking our slope is actually negative 3 over 1. We can look at it that way. Go down 1, 2, 3, go over to the right, 1. 1, 2, 3, over to the right, 1. And then we get an intersection point, which I think is 1, 1, all right? I'm going to go confirm that with Desmos really quickly. So what I love about Desmos is that it does these beautiful graphs. So if you are not familiar with it, it is an app that you probably have on your iPad. And if you don't, make sure you get it. So here I am. You can go to the interweb, type in Desmos into the address bar, and do what I'm doing, and you totally get started. And so I'm going to graph those two equations. So y equals x, I'm just plugging that right in there, and there's the line, the diagonal line I mentioned. And then I'm going to go on to another equation, and that was y equals negative 3x plus 4, I think. So y equals negative 3x plus 4, literally just typing it in. And look at this beautiful graph, right? Both of them were gorgeous. And if I click right here on the intersection, I see that the intersection, I hope you can see that, is 1, 1. So my speculation about my poor graphing, because I was being really loose, was true. The intersection point is 1, 1. So going back to our lesson, the solution to this is 1, 1. Do I expect you to use Desmos when it says solve the equation by graphing? The answer is no. I expect you to actually graph it. But graphing with this device is really hard, so I thought you'd appreciate the beauty of Desmos. Next question. So here's example 2. We've got Mary and Brian, and they're selling magazine subscriptions. Mary sells 3 times as many subscriptions as Brian. Brian sells 12 fewer subscriptions as Mary. We're going to write a system of equations for the situation, and then we're going to solve the system by graphing and explain what the solution means. So first thing that's really important when we do problems like this is to define things. So I'm going to define what Mary, so I'm going to let Mary, the number of Mary's subscriptions, so Mary's subscriptions will be Y. And let's let Brian's subscriptions, his number of subscriptions, I should put number of Mary's subscriptions, and number of Brian's subscriptions will equal to X. All right, so we have two equations that they gave us here. They told us the first thing is that Mary sells, the amount that Mary sells is equal to 3 times as many as Brian. So what that means is Y is equal to 3X, okay? And then the next is that Brian sells 12 fewer subscriptions as Mary. So Brian, he sells 12 fewer. The temptation is to do X minus 12 equals Y, but if he sells fewer, to make them equal, you'd need to add 12. Does that make sense? X plus 12 is equal to Y, right? Because fewer, got me? So here we have these two equations that we need to graph and figure out. I'm going to change the second equation into Y equals X plus 12, so we can look at the two equations distinctly, and we're going to talk about graphing them again. So if I am to graph it, I need my X and Y axis. I'm doing this very rough and freehand. We can use Desmos to confirm. I'm going to have Y equals 3X. That graph, this yellow one, will pass through the origin, and it will be somewhat steep. For every one part it goes out, it'll go up 3. And then so you're going to have something that looks kind of like that. And this one is going to be X plus 12. So what that means is my Y-intercept is 12, so it's going to be somewhere up here. And I'm doing this very roughly. And then the slope is going to be up 1 over 1, up 1 over 1. So you'll get some points that do this. Now you can see that this is absolutely not precise at all. So I am going to use Desmos, though I know you guys have the ability to use wonderful graph paper, and so I don't expect you to need to use Desmos, but I'm going to use Desmos so we can kind of bring home the point. I'm thinking about these two equations, and I'm going to go and graph them. So let me go ahead and get my very cool graphing calculator, which is Y equals 3X, and the other one, have I forgotten what it was? Let me think. X plus 12, X plus 12. And I see that I can't figure out where the intersection is. But the cool thing is I can put 2 fingers on my computer touch pad there, and I can figure out where the intersection is. And the intersection is at 618. And so that's pretty awesome. I'm going to go back to Notability and put that information in there so that these guys intersect at 618. And so let's talk about what that means. So this is, for all intents and purposes, done. What does that mean? It means that the ordered pair 6 and 18 satisfy this equation. So if I put 18 is equal to 3 times 6, that's me plugging it into this equation and checking it out, and you can see that that's true, that works. And I can also plug the 6 and 18 into this equation, and I get 18 is equal to 6 plus 12. So that's what it means that it satisfies it. So as cool as that is, graphing is not an exact situation, right? So the reason why I'm talking about that is because not this situation, but the next time we're going to actually look at graphing, not graphing, but solving these with algebra, because algebraically we can get more specific with our answers. So here's example 3. No solution in infinitely many solutions. So I'm going to just talk about this concept really quickly before we get started. So no solution would look like this. So here's no solution. No solution to a system of linear equations or a system of equations in general means that they don't intersect. So you could have a situation where the lines are parallel. If you have 2 lines and they're parallel, there is no solution. And another solution you could have is infinitely many solutions. Infinitely many solutions. And that situation looks like this. You've got this line, you graph it, and you see that's one line. And then when you go to graph the next equation, it's exactly on top of it. And so basically what you have is a situation where both of your equations are really the same, so every solution works. Here, no solution works. Here, every solution works. And that's what we'll discuss here. So I'm going to delete this. That was just my little sidebar. And we'll talk talk more specifically about these examples. So let's look over here. When I look at this problem, what I'm noticing is something really important. The slopes are the same. When the slope is the same, that means that those lines are parallel. So already I know that there are no solutions to this system. So when I graph it, I'm going to get that my y-intercept for, let's say, this first equation, let's do it in yellow. My y-intercept for that first equation is 1, and my slope is -1. So I'm doing one of these numbers. Okay, I almost had a beautiful line. And then the next equation, let's do this one in green, has a y-intercept of -3, 1, 2, 3, and it has a similar slope. Not a similar slope, but the same slope as the other guy. And these guys, though my crooked lines will eventually meet because they're crooked, then these guys were drawn straight and perfect, you would see that they would never intersect. Over here, we have y is equal to 2x plus 4, and y is equal to 1/2 y is equal to, 1/2 y minus x is equal to 2. If I were to manipulate this equation a little bit to make it easier to graph, one of the things that I would do is I would multiply both sides by 2. Okay? So if I multiply this side by 2, this side by 2, the first equation I'm just rewriting is y is equal to 2x plus 4. This second equation, I'm going to distribute that 2 through, so I get y minus, distributing 2 again, 2x is equal to 4. Already as you look at this, you can see that with a minor adjustment of moving that -2x to the other side, I have exactly the same line. And so the need to graph the same line is strong right now, so I'm going to do that. So I've got 1, 2, 3, 4. And the slope is up 2 over 1. So here's the first line, and if I want to call the second line done in green, if I were just to solve for y, I'd see that the second line is right on top. So that means that's infinitely many. Sometimes that happens. Finally, this is what I've been waiting for. How do we solve problems by substitution? When you have, so this is pretty basic, right? If I have the equation y is equal to 5 and the equation y is equal to x plus 2, if y is equal to 5, I'm going to substitute it right in here and solve the equation. So I would say, oh, taking these two equations together, I'm going to put a 5 there. 5 is equal to x plus 2. And now that's just one variable equation. I can knock that out. If 5 is equal to x plus 2, what I'll do is I will isolate the x by subtracting 2 on both sides, and voila, x is equal to 3. Not that big a deal. X is equal to 3. We already had y is equal to 2. My ordered pair, or the solution to this, is 3, 5. Over here, slightly different situation, but the beauty is that y is solved for in both equations. This gives me the power to substitute. So here, if y is equal to 2x plus 1, and at the same time y is equal to negative x plus 5, then that means that negative x plus 5 must equal 2x plus 1. Because we're referring to the same y, or at least we're trying to consider, are we talking, well, that we're talking about the same y. So again, the beauty of this is that now I have one variable. I'm going to isolate that variable. I don't like using this color. I'm going to isolate that variable. I'm going to move my x's over to the left side. And when I do that, I'm left with 3x plus 1 is equal to 5. Subtract 1 on both sides. And what I get is that 3x is equal to 5 minus 1, which is 4. This doesn't come out really pretty, but that's okay. X is equal to 4 over 3. So though not pretty, I'm going to take that value, and so x is equal to that. To figure out what y is, I'm going to plug x into either one of these equations. Let's plug it into the second. Y is equal to negative 4 over 3 plus, let's make this more convenient, I'm going to call 5 15 over 3. Notice that y is equal to 11 over 3. So the ordered pair that I'm suggesting satisfies these two equations is these two, or are these two. And that would be interesting to see if that matches up on Desmos. So I'm going to do a quick switch over and we're going to confirm that. So you can see my two equations here, and there's the intersection point. When I click on that point, I get 1.33, which is 4/3, and 3 point, I believe that's 66666 going on. They rounded it to 67, and you know what that is, 11 over 3. I think that's pretty awesome. I look forward to talking to you more soon about substitution and anything else in math. Have a very good evening. Bye-bye.